Uh, Good afternoon, everybody. My name is Vito Giordarno. I'm actually a neuroscientist doing a lot of research, and we're using neuromonitoring and looking at the outcome of premature infants. But since almost 5 years now, I'm also investigating the noise level in the NICU. So I'm going to present some data about that with this provocating title, The Sound of Silence, because I have realized after performing some measurement at my units that our NICU are not such silent as we thought. So my presentation will be built in the following way. I will briefly talk about the hearing experience in human. I'm probably sure most of you know about that, but I will need to do that to contextualize how it looks like by the fetal and premature hearing experience. I will then present data about noise level in the NICU and contextualize also the soundscape of the NICU with some outcome data regarding language outcome of our patients. So my presentation is based on this trilogy of study, The Sound of Silence, Living in a Box, and Every Breath You Take. And if you think I've used ChatGPT to make this title, you are wrong. I'm simply a passionate musician. And at the time there was no ChatGPT available. Anyway, I'm only a part of a big team, and the special thanks goes to these two persons here, which are professor in acoustic engineer and provide the quality of the study we did. So now we start with the first question. Would you best describe the noise level in your neonatal unit? Very noisy or very silent? Loud? Not perfect, dry. Loud. Improving. Oh, that's a nice adjective. Many conversations at once, that something happened. Boom. The emoji is fine. I like it. Yes, it so the pool is still active. We can't live in that environment. Oh my God. Then think about premature. When I present data on premature infants, you will say they could not live in that environment as well because they are exposed to much more noise than we are. But the main, it's loud. Yeah, I thought actually that our unit was not such loud, but after making some measurement, I have to reconsider my, my thought about that. As I mentioned before, to understand how it works with the fetal and then the premature hearing experience, I would briefly go through the human adult hearing experience. And basically, it is like this, that the sound enters the ear canal, then the eardrums vibrate, and by vibrating produce the movement of the bones present in the middle ear, which further ripple the fluid within the cochlea, this little fantastic structure present in our ear system, and the air cell within the cochlea will move and produce a general an evocative potential, which will then be transmitted to the brain. I think it is important to say that the human hearing experience is unique, and this does not only depend from the source of the sound in a room. For example, people sitting left or right will recognize my speaking differently, but it's also depend by basic stuff like the morphology of your earlobe, of your pin, and the way the sound is accommodated in the ear, as well as to the length of the ear canal, which will be responsible for different sensitivity to different frequencies. If you look at, now, if you consider that the ear canal is a kind of half open tube, it has a kind of resonance. And if you consider the transmission of sounds in the air being about 340 meter per second, then we can, by applying this formula, understand which is the resonance within the ear canal, which is slightly different from person to person. And in the mean, this will be about 3000 hertz. I will show you then after what does it mean, because it's important to say. Now, again, a little movie about how it works. The sound enters the ear canal, the eardrums vibrate and generate the movement of the ear bones. The ear bones stimulate the cochlea, this little fantastic organ able to respond to a very huge different kind of frequencies. The air cells within the cochlea moves and produce and evoke a potential that is transmitted to the brain after that. So in which frequencies range do you think we can hear? So this is a kind of tricky question, because actually literature report that we can hear between 20 and 20 kilohertz. But now I'm going to show you what does it really mean. Can I go further? Yes. So now we'll need this example. I will stop talking because otherwise there would be a vibration. And these are 20 hertz. Do you hear something? No, right? So we don't have. Can you increase the? In 20 and 20 kilohertz, but actually we do not recognize all frequencies equally. And some frequencies are also recognized as uncomfortable. So when the frequencies get higher, then it adds also to our hearing system. As I told you before, we have a kind of resonance within 3000 kilohertz, but the language spectrum is it's very bright. And just by information, it varies slightly from spoken language to spoken language. So you will not have, for example, Spanish being the same range of English. When we talk about noise, sound level, it is important now to combine frequencies with decibel. Decibel should be recognized not as a linear scale value. It's just a proportion. It's a proportion of sound that gives us a feeling about how loud it is. And in most of the paper, you will find the threshold of 0 as compared with no noise, quiet environment. But actually, for example, in the music industry, by mixing and mastering, 0 is put to the middle, because then you can work better with bass and high frequencies. Now, it is important to understand that there is a kind of curve adaptation about decibel, which is called dBA. So when you read paper and you find dBA, it means that the sound level is adjusted to the frequencies. So for the example before showed you that by 20 hertz, you could not really hear something. But probably it's just a question of decibel. So if we add decibel to a given frequencies, then we can reach also the hearing to that sound. Okay, so that's the mixture about frequencies and decibel, and it is important to understand by looking at the fetal hearing experience. So, and now this was a kind of little introduction for how we perceive sound. And I will show you how it works now with the fetus. A couple of years ago, we wanted also to produce a kind of intrauterine stimulus to reproduce in the incubator. Then we figured out that this could be an invasive measurement, and we avoid doing that. But in the internet, you can find everything. And the National Geographic did the job for us. And this is... So I think it's enough. You hear a very damped sound, and in the intrauterine environment, baby are are extremely protected from a bunch of frequencies we usually hear during our daily life, like high frequencies. So only bass frequencies pass through the tissue, and the sound is attenuated by 20 to 35 decibels. So it's very, very a quiet environment within the womb. And now there is a fantastic publication, one of those publications that you really enjoy to read from Lahav and Sko, due in 2014, that get really the point about the difference between being in the womb and in the NICU environment. The first thing to consider is that in the womb, the hearing system is most based on bone conduction. So not really active with the ear, but bone conduction. While in the NICU, we are talking about air conduction. The speed of sound, I mentioned before, this 3,000 hertz resonance. So again, there is a huge attenuation of the sound within the womb. The sound is primarily in low frequencies, and the kind of noise are a noise. The sound the baby is exposed to are very qualitative, sounds, like maternal voice, like heartbeat, and they are rhythm periodic. But the way, for example, prosody, which is a rhythm of the language, is used by the baby to learn a language also. While in the NICU, what happened? There are the sound is not filtered at all, so they are exposed to almost a very huge, a very bright frequency spectrum. Those noises are excessive daily, mostly related to electronical devices. They have a poor quality and they are aperiodic, sadly. And now try to imagine what does it mean for you if middle in the night an alarm clock start to alarming. It's also a kind of disturbing your sleep structure, which is essential in premature infants, and this also strongly related to neurodevelopmental outcome. So again, we were talking before about the resonance of the ear in adults, which is about 3,000 hertz. It's not really the same in newborn, which is mostly around 6,000 hertz, and decrease over the time, reaching the same adult experience around 37 months. We have tried to translate this information considering the fact that in intrauterine, the sound is not transmitted with 350 meters per second. It's most slowly with 4,084 meters per second, achieving a resonance of in the ear canal about 26,000 hertz. What does it mean? This is far above the range of the human hearing system. So mostly we can assume that babies are protected from any kind of acute frequencies. But it's not only an assumption. So also in 2014, a fantastic publication from Lasky and colleagues published in Pediatrics in 2014. We all know that there is a brain maturation going on between the 23 weeks of gestation to the 40 weeks of gestation. And it's the same for the hearing system. Important to say, a long story making short, that a lot happened between the 25 weeks of gestation and the 32 weeks of gestation, because one could argue, can premature infants hear something if there is a different hearing experience? And the answer is yes. Actually, for me, it was also interesting to know how people could measure that. And so I'm going to present you this publication, which are old but gold. And these are the publications that are usually mentioned in such study by Mlaski and colleagues, where we are kind of sure that a fetus or a premature infant can hear something up to the 25 weeks of gestation. So for example, Binolds and colleagues, 40 years ago, they used high resolution ultrasound to measure eye blink. And basically they found out that by stimulating by 110 decibel, they could look at this eye blink response starting by the 24 weeks of gestation. But as I mentioned before, it's not all about decibel, it's also about frequencies. And Hepper and colleagues, they complete this information by presenting by stimulating the baby, the fetus intrauterine with different kind of frequencies. They could demonstrate a first response around 90 gestational weeks, but a stable response was present at 27. Now, what happened when the baby is extrauterine? Does this information come to the brain? Can this information somehow be elaborated from the brain? And the answer also in this case is yes. And colleagues, they've looked at the vocal potential, acoustic vocal potential, and to make the story easy, the black box here represent a major acoustic potential where peak 3 and 5 are present. And as you can see in the graphic, these maturing waves are starting to be recorded at 26 weeks of gestation. They're almost present between 28 and then strongly dominate at 31 weeks of gestation. So the answer is yes, the baby can hear, yes, they're exposed to the sound, and the brain can also recognize this kind of sound. So my first conclusion is that the extrauterine hearing experience significantly differ from the intrauterine experience, that there is a rapid physiological growth also for the hearing system going on between the 90 and the 35 gestational weeks, that all study shows that this kind of, that acoustic can be recognized starting by 25 weeks of gestation. And therefore, as the brain growth, also acoustic can somehow modify the development of the brain. So here's come my next question, which is the recommended noise level in the NICU. Should I go further? Yeah, okay. The recommended noise level is 45 decibel. This is a recommendation from the American Academy of Pediatrics. But now in the following slide, I will show you how impossible this is to maintain this value. In the previous slide, I showed you we make some noise measurement, and we were very afraid of our results because we measured extremely noise environment in our NICU. So we thought maybe it's the case to compare ourselves with the world. And I've started a systematic review. These are preliminary results about that. We included 107 study from 2000 study we have found. The quality of those studies not excessive, but anyway, it's a way to start. And here we are. The line in the middle that represent the 45 decibel from the American Academy of Pediatrics, this limits, and almost all the study when considering the 24 hours mean noise far exceed this line. And it doesn't matter which level of the NICU you are. So we thought about which is the proportion between day and night. And by the way, the American Academy of Pediatrics says that during the night, the level should be 35 decibel and not 45 decibel. So even if there is a kind of differences in some study measured between the day and the night, at the end, we are far above the limit of the 45 decibel. And this is how we compared ourselves with the literature. So for us, it's kind of comforting, but for the NICU, is a kind of impressive value to consider because so we divided our data in environment, handling, and respiratory support. And as you can see, we somehow fits within the literature, and no one is presenting data under the 35 decibel. I'm very sorry to say that. So it's very noisy environment, and if you think about being adult and working in such a noisy environment, it is stated that working daily for more than 8 hours over 85 decibel, it produces a nearing shift. So now try to imagine what happened in premature infants, which are exposed actually more than, this is only the noise within the NICU, and we are coming now to the incubator. So Manson and colleagues, they did a study published in Journal of Perinatology in 2020, where they said that the incubator protects the infant even more than the womb does. Maybe good news, not really, because it protects in some frequencies that are relevant for language. And that's something I will show you then also after. So we did also a similar study. This is the first study we did. It's called The Sound of Silence. We used the Traeger isolated incubator, Paul as mannequin. We calibrated all our microphone in an echoing chamber room, and we had a bunch of stimuli we use. This was our library, and we tested all our library for 3 different conditions, which was cover of the incubator, which is usually used for light, but we thought maybe has also an impact on acoustic. Then we look at the doors, if they are open or closed, and then we look at the flow. We use CPAP at different flow level. And I'm not going to present all those stuff, but just to give you some example, this is a reduction of broadband noise. It sounds like that. Okay. So you can hear the reduction of the stimulus. That's a stimulus we produce. And now look inside the incubator with the flow. The stimuli are different. Can you hear any? So the stimulus are similar but different. But if the CPAP is on, you cannot really recognize a stepping down of the frequencies we have used. So the take-home message from this slide is that when you're using respiratory supports, it's the noise inside. It's covering everything else. And now another acoustic stimulus is that then there is not only one, and we are ready with that. So cover your ear with, for this one, we can because can be at the beginning. No. Not yet. Are you still alive? Well, so if we look now, we use different frequencies to understand also in which frequencies ranges the incubator save us. And if we'll look at this graph. I will not present the stimulus again because it's very annoying. But what happened, what we see is that within the incubator, the dorsal cross, we're stimulating from outside. There is, and this is the NICU environment outside the incubator. It makes a kind of U shape, which means that the bus frequencies are strongly represented, but similar to middle and high frequencies. In the incubator, the bus frequencies are boosted. And why this happened? Because the incubator, it's a kind of cavity. Try to figure out the incubator as a guitar, as an acoustic guitar. The acoustic guitar amplified, the corpus of the guitar amplified the sound, and the same happened within those frequencies for the incubator. Okay? So some frequencies will be amplified within the incubator, and some other frequencies are still within the incubator. So it's a kind of never-ending noise. This is the last acoustic stimulus. Is simple.
Hallo, meine Kleine. Wie geht es dir heute? Twinkle, twinkle, little star, how I wonder where you are.
Yeah. So that was the last stimulus. It was technical, difficult, but we did it. So in general, we can say that if parents are talking from outside, the baby will probably not hear anything about that. What inside the incubator happen, there is a boost of bus frequencies, but an excessive reduction of middle high frequencies, as showed by Monson and colleagues in the slide I've shown you before, which means all the frequencies in language ranges are attenuated, while other frequencies where the fetus is used to be exposed, these low frequencies are boosted. Can you remember at the beginning I've said the baby in the womb mostly is exposed to bus frequencies, right? But in a reduced range. In the incubator is like the best frequencies are boosted. So the frequencies where they are more used to react, they are boosted, and the other where the language is found, so that could be stimulate language acquisition by the infant, is attenuated. So if there is the respiratory support, then it's a chaos, because also the high frequencies significantly boost at a decibel level that it's not natural, not human, where no one should be exposed to. I'm not going to show this slide. This is only for teaching purpose. We did a virtual reality video about that. So if you want to be in the position of Paul and having a CPAP, you can do that if you have a virtual reality glasses at home. It's just for purpose. You can find the link also in the publication, so you don't have to make a photo or something like that. Simply look at the publication and you find the link. And now we are going to the last study, every breath you take. We have compared different solution like CPAP with bronchs or with mask, or nasal cannula and endotracheal tube, and you can simply deduct from the picture here how noisy is the when we use the CPAP, and we also have tried to give a feeling of which frequencies are involved by presenting the DBR curves, so preterm, newborn, and adults. And as you can see, CPAP cover not only in decibel, but also the frequencies that are more where the infant are more sensitive. Again, this is little information about that. We have made a mathematical model about this resonance of the incubator. So this vibration, this natural vibration in bus frequencies, because we wanted to understand what does it mean. And the vibration of the incubator, or the vibration within the incubator of the sounds in these frequencies produce an increase of the sound of 28 decibel, which is impressive. So the conclusion from my second part is about noise level in the NICU far exceed the recommended level of the American Academy of Pediatrics. And this is not only something we measured in our unit, we contextualize also that with the literature, and everywhere is like that. We have a boost of pulse frequencies within the incubator and a strong reduction of frequencies that are important for language acquisition. And now we move to language problems. In premature infants, I will show you how the sound landscape of the NICU can impact the language of the premature infants. So we all know that premature infants have a lot of problem in outcome. We have heard about autism, about ADHD, and language as high cognitive function belong also to this kind of problem. And as measured by Van Noort and colleagues, this also is independently from variable like socioeconomic status and persist later on in the outcome when they are when the babies get older. So in our department, we have a cognitive neuroscience lab where we use near-infrared spectroscopy to measure hemodynamic change in the brain activity by baby exposure to speech. So we do study by using this kind of methodology, which is not the same of NIRS. So no boost trial, no such stuff. And basically it works like that. I have only a little video. The green line means someone is starting to speaking. So when someone starts to speaking, you will now...
Dann stört ein Laubfrosch seine Ruhe und fragt das Tier, wer bist denn du?
Yeah,
Da steht es und stutzt und guckt.
Yeah, that was an example. You see it getting red, which means there is an increase in the hemodynamic response in the left hemisphere. By using a sophisticated tool like MATLAB and Python, we can map these things, and we can map also the whole brain. But what we do not use is a constant hemodynamic response. We use something called block design, because each baby has his own hemodynamic response. So we just stimulate 14 times with speech, and we compare that with a baseline and with reverse speech to having a feeling about how the brain react to language stimuli. So this is, for example, one of our study when we compared full-term and preterm babies. And we find out that the left hemisphere of full-term babies was significantly different activated when exposed to language compared to premature infants, and that there was also within the full-term infants a difference between the left and right hemisphere hemodynamic response. So we assume that actually the premature infants cannot really differentiate speech. And then we ask ourselves if it's like that, there is a kind of cutoff in the gestational weeks that we can identify. And we use the same methods. We use a cluster analysis to try to figure out at which point there is a higher risk for language development. And this was defined by the 32 gestational weeks where two different clusters were identified. But now I think we are coming to the point where we combine language outcome with NICU sound noise landscape. And this is the publication done from the group of Terry Indar, so one of the strongest group in MRI outcome, and published by Roberta Pineda in Journal of Pediatrics in 2014. These are, the picture are about secondary outcome of the study, where they have simply compared what does it mean to be in a single room versus open ward NICU. And they were extremely surprised, as each of us, to find out that maybe in a single room, they had actually worst outcome in terms of temporal lobe maturation compared to baby that was in open wards. They were extremely surprised, so they follow up the babies and they find these differences also in the Bailey scale of infant development. So now I'm coming to the point. There are other studies where they investigated parental communication with the baby, and they show a direct association between parental wording and Bailey scale outcome in the Bailey scale language subscales. And other study also showing that by implementing a kind of intervention where maternal voice and heartbeat were combined 3 times a day, they found an increased maturation of the temporal lobe for the temporal lobe, which is obviously associated with language development. So my conclusion, my third conclusion, and my last conclusion is that language deficits are higher in the population of premature infants, that differences in brain activation related to language stimuli have been measured at term equivalent with 32 gestation windows has been found as kind of cutoff to predict the language problematic after, and that the acoustic deprivation may lead to worst language outcome in those babies. So maybe the adequate environment and stimulation could support the brain maturation and the outcome. So what is the take-home message? It's not about it's not only about the noise the baby are exposed to. It's also we have to find a balance between a quiet environment and adequate stimulation. Adequate stimulation, I think, is a key word to improving outcome for those babies. Do you think your neonatal unit should be quieter? So almost 80% say yes, which it's quite interesting because, yeah, noise can modify and shape the brain development of the baby and modifying also the outcome. So we should be more aware about the noise in the NICU and also applying adequate stimulation for those baby. In this regard, we are starting a trial called the SENSE trial, combining the information we got from our study about noise level with the information from the group of Derinda, where a complete isolation lead to a worst outcome in language. So we think the right stimulation at the right time would improve a lot the outcome of the baby. The NICU has developed increasingly over the year, particularly from a technological point of view. I think by adjusting also the environment, we could also provide the benefit for the outcome. So we are developing this program together with the group of Roberta Pineda, where we stimulate not only, we pay attention to the noise, but we stimulate also at the right time by, for example, reading, music therapy, or for example, paying attention to the light environment, the smell. So we are combining we have a kind of program for each gestational week to support the baby and stimulate the baby in the right way. Thank you very much for your attention.